something about the movable pulleys, which is read under laws of motion. They are also read under the heading of constraint equations. Now, what is a movable pulley? We have two kinds of pulleys. One is fixed pulleys, the other is movable pulley. Fixed pulleys and movable pulleys. What is a fixed pulley? You have done questions where you had a pulley, over here you have a block, over here you have a block, and something like this. So this pulley, it can rotate only. This rotates. This doesn't translate. There is no translatory motion. It purely rotates. And for convenience, we know that generally the pulleys which you are dealing with, they are massless and they are frictionless. As soon as in your examination, the mass of the pulley is given, then it means that the chances there, this question belongs to rotational mechanics. If it is given massless, frictionless, then it is more or less from laws of motion only, or Newton's laws of motion. So this is fixed pulley. Now what is a movable pulley? Movable pulley is which can move. It is not rotate, which can move. That is translatory motion is there. Like, if I take a simple case, this is a pulley, string is going like this, and over here I have a block fixed over here. This is a center, from here I pull it by let's say by a distance x. When I pull it, and this string is tied to the, let's say, this wall, so this is fixed. When I pull it, this pulley, when I pull it, this pulley will rotate also and this will translate also. So this is movable pulley. This moves. As a result, obviously, this block will also move this way. This block will also move this way. So this is a movable pulley. This is a fixed pulley. There is translatory motion is there. There is no translatory motion. Now when we are going to deal with the questions like this, questions on movable pulley, or what you call as constraint equations or constraint motions, then we shall be using some of the concepts of fixed pulleys. Number one, that is, pulley is massless, frictionless, and over here, if tension is T, then in this string the tension is 2T. You know that. That is, in massless string, that is ideal string, massless, inextensible string, you know, because this is massless, then the tension throughout the string is same. Whereas, had it been a rope, rope is a string which has got mass, and suppose the system is accelerating, then throughout the rope you can have different tensions. But in string, tension is same. In one string we have one tension. And if tension is over here T, over here also T, and over here that is due to 2T. Right? So, in the central string, the tension is double of the, let's say, tension in this string, which is going around the pulley. Provide the pulley is massless. Similarly over here also, that is my pulley is massless. So, if I call this as T, T is here, so in this string, it has 2T. Remember this. That is one thing. The second is acceleration relationships. Now, what is that acceleration relationships? Now, let's understand that is, when I draw a fixed pulley, suppose I pull it by x, so this also goes by x. If I divide by t, x by t, you can call x by t velocity, or dx by dt you can say instantaneous velocity. So what's the velocity? I say velocity is of this block A down, so B is also going to go up with the same velocity. Once again, if I differentiate with respect to time, then d by dt, that is acceleration, if it has acceleration A down, it has acceleration A up. Simple. Now, going to the movable pulleys. Now what happens in movable pulley? Let's see. This is a pulley, string goes over here, there is a block, let me call it A, over here, let me let's say connect one more block, I call it B, and this is movable pulley. you say 1 meter, 2 meters, etc., students I have observed, they understand in a better manner. Let me take the length of the string total. This is a point pulley. So don't get into the dimensions of pulley. That is what is the radius and all those things. Suppose this length is 10 meter. This is 8 meter. Don't bother about this length. So total length of the string is 10 plus 8, 18 meter. 18 meter is the length. Once again, this is also point mass. So this is 10 meter, this is 8 meter, so this is going to be 2 meter only. So distance of this from the wall is just 2 meter. Now what I do is, I pull this block by 1 meter. So from here to here, I see this is a single string. This is a single string. If I pull my hand by 1 meter, this elbow is also going to pull by 1 meter. If this is a string, you pull it by 1 meter, this will also go by 1 meter. So as a result, this pulley will also move by 1 meter. If this pulley moves by 1 meter, if I say that this goes by 1 meter, suppose. So now, corresponding diagram is going to something like this. This block moves up, moves in this direction. Now, if this is 1 meter, so once again, I write 2 meter over here. So this was from here to here 10 meter. 1 meter I have pulled, so this is 1 meter. If this is 1 meter, so this is also 1 meter. Total length of string is 10 plus 8, 18 meter. Now I observe 10, 11, 12. So this is 12. Total length is 18 meter. 18 minus 12, so obviously this is 6 meter only. So now, when I pull this by 1 meter, so over here I observe 10 plus 11, 11 meter. So this is 12, 1 meter. 10 plus 1 plus 1, 12, so this has to be 6. So the total length is 18 meter only. This is 11, this is 7, so it means this is 4 meter. Right? 10 plus 1, 11. 4 plus 6 plus 1, 11 meter. So it means this block, now how much far away it is from this wall? It is 4 meter. What I have done, I have put this by 1 meter, I have put this center by 1 meter, and this I have seen that this has moved by 2 meter. Initially it is 2 meter length, 2 meter distance. Now this block is at a distance of 4 meter from the wall. It means this block has moved by 2 meter when I have pulled this center by 1 meter. This is an important observation. If I pull this by 1 meter, this moves by 2 meter provided the other end is fixed. Please understand it. I can also put a block over here, then the things will change. We'll do later on. Now for convenience, I have fixed one of the strings, I have fixed. And the other one is obviously the horizontal only, they are straight. I could have also made an angle also on the string, the things would have changed. Anyway, so when this moves by 1 meter, this moves by 2 meter. Now let's understand in some other way. Putting the same thing in slightly as a different language, I say I have pulled it by distance x. This center I have pulled it by distance x. Or over here if I block, if I pull it by distance x, so this also moves by distance x. When I have moved by distance x, so the pulley will be going over here. As a result, this will be like this. So if this distance is x, x string is required here, x string is required here, 2x string is required. The requirement is 2x. The total length of string is constant. String cannot be created. The total length is constant. So they have to be accommodated. Who will accommodate? This cannot move. So as a result, to make the total length as constant, this moves by 2x. In the same time, when it moves from here to here in time t, this will not say you go, I'll come later on. No, it doesn't say like this. It has also to move from here to here in the same time t. X by t, you make it a velocity. Or this, when you are calling x by t as velocity, 2x by t. So this velocity is going to be 2v. Similarly, once again you can differentiate with respect to time, and you can say if its acceleration is a, this acceleration is will see in your questions. This section you will see. Even the question which you are going to follow, we will see this. Or let's say, I put it slightly, let's say, in terms of bit of maths, if you wish to put it, this I call it as A, this as B. Suppose this moves this way, we have to find the velocity of this wall. From the wall, I say let this distance is x, and let's say this distance is y. So total is x, this length is x, this is y. So this is going to be x minus y from here to here. This is a point mass once again. Do not consider the dimension of this block. This is a point mass. So total length, this plus this is equal to constant. So I say x plus x minus y is equal to length, that is a constant one. So I say 2x minus y is equal to L. If I differentiate it with respect to time, dx by dt. dx by dt is, that is how x is changing with respect to time. That is velocity of A. So if I differentiate with respect to time, so I get 2 dx by dt. That is, I directly call it as VA, velocity of A, minus dy by dt. It is all the distance they have been taken from the wall. How the y is changing, that is the distance of B is changing with respect to the wall. dy by dt, that is velocity of B. That is what you are going to see from the wall. Or I observe over here. So that is VB. L is constant. You know the derivative constant, that is equal to VB. So 2VA is equal to VB. Or that same thing. That is, you can say VB is equal to 2VA. Is the velocity of this. I should have been using this. I have used cap. So let me make it capital. Velocity of B is 2 times velocity of A. Once again, if you differentiate, you will say acceleration of B is 2 acceleration of A in parts. The same thing we have done in these 2 or 3 types. We have done the same thing, right? So AB is equal to 2B. Whenever you get a movable pulley, so now what are the things you have to take care of? I repeat once again, that is what are the things you have to take care of as soon as you come across a movable pulley. Number one is strike at 2 places. Remember, to strike at 2 places. One is acceleration relationships, the other is tension relationships in the springs. This is massless. So T is here, 2T is here. Number one thing. Tension relation done. Second is, if you are going to pull it by A, this is going to be pulled by 2B. Then you can simply make the equations and you can get the answers. So simple. Let's solve 1 or 2 questions using this. This is, I say, 10 kg. Let's say for convenience also, I say this is also 10 kg. This is a wall, all surfaces are frictionless. Wires or strings, they are purely horizontal or vertical. So this is a fixed pulley which can purely rotate. This is a movable pulley. So as soon as you see a question, be very clear that is how many fixed pulleys, which are the fixed pulleys and which are movable pulleys. Be very clear about things, what you are doing and even how you are thinking about also. So over here, that is one of the mistakes generally the students they do is, if they are not aware of movable pulley, which is obviously is the basics of, these are the basic questions when you prepare for your entrance examination like IIT or medical or even NEET-PMT also. So this is the basic questions, right? Please do not make a mistake, which many students make is, they say, sir, net force is 100 Newton, total mass is 10 and 20, into A you get the acceleration. This is wrong. You cannot do that. The reason being, as soon as movable pulley comes, there is acceleration relationships. Acceleration, they are not same. channel two ways. I restrict my thinking initially just to tensions and accelerations. So over here, if I mention T, so obviously T is also here also. I'm not talking about this, so this is 2T. Tension, image, strength, remember. So to say tension of body, no, it is not tension of body. Tension is strength, acceleration of body. So when I draw a free body diagram for this is 2D, it is not supported, 100 Newton in this way. This is tension relationships. I jump to forces. Before that, let me take the action relationships. If this goes by A, this block goes on by the acceleration A, this pulley will go by, do not say two-way. From here to here, please see, this is like a train. You see that this is a train of blocks. If this goes by A, acceleration A, action remains same. This is also from here to here, this is single string. It is a train going downhill. So if you pull this by A, this is also pulled by A. Do not say two-way. So when this is going to pull by A, so this you remember, this goes by X or 2X we have done it, or A or 2A we have done it. If you are going to pull by A, so this is going to pull by 2A. Now we make the equations. T is here. Tension is in this direction. You know that is, you will not be considering now 100 Newton. I have taken over here GS 10 meter per second square instead of 9.81 meter per second square, just to avoid unnecessary waste of time in the calculation. But in examination, be very clear, that is what is the value you have to take. Look for the options, what are A, B, C, D options. If the difference between the options, values is huge, then you can go for approximate calculations. If they are very close, then be precise. Anyway, so 100 Newton is this, 2T is this. So equation for this goes 100 because it is accelerating down. Do not say it is going down. It can happen that it is going down but accelerating up. There could be cases like this. So whenever you say that is it is accelerating down. So that's why 100 minus 2T. This is net force. When you say F equal to ma, F stands for F. Do not say F stands for force. F stands for resultant force, net force, unbalanced force. Though many times we use the word total force, but I think total is primarily used for the scalar quantities. For vector it is, I think it is better to use the word resultant or net. So 100 minus 2T is the net force. 100 minus 2T, net force is equal to mass. Story of this 10 kg block is going on. So mass is 10 into weight. That is one equation. Now for this, all the surfaces they are frictionless. The only force which is trying to move it this way is tension only. So I say T. F is equal to m. T is equal to 10 into 2a. You have two equations. You can multiply by 2, then minus 2t plus 2t etc. They will get cancelled and you know how to solve it. Simultaneous equations. Not a big deal. So from here you can solve the values of acceleration and tension also. Okay, now one mistake which is generally that is many times students they do is, suppose the acceleration of this, suppose it comes out to be let's say 2 meter per second square. Suppose it comes out 2 meter per second square. In the examination they have asked the acceleration of this and they make the first choice as 2 meter per second square. You have found the value of A, you are happy, okay, 2 meter per second square, you have got the right answer. So on the first one you take it. No. You have to see all the 4 choices before you jump to the answer. Be very clear. You have to see all the 4 choices. Over here acceleration is 2 meter per second square of this. And this is going to have a 4 meter per second square. So answer is not 2 meter per second square, but answer is 4 meter per second square. And it may happen that they may give this answer as the last choice, D choice. Right? So this is how you deal with the basic questions of movable pulley. Let me take 1 or 2 more simple cases to elucidate that is how these questions they can be done. Once again, movable pulleys. Don't think this is, there are some angles, there are no angles, they are straight, almost straight only. Once again for convenience, I say 10 kg and 5 kg. Be very clear. Number one, how many pulleys are there? You say 1, 2, 3, 3 pulleys. I say what's a fixed pulleys? Fixed pulleys which only rotates, which doesn't translate. So here if I see this is a fixed pulley. This only rotates. Over here, if it goes down, this will be rotating. When this is rotating and translating, this will also be rotating and translating. So this and this, they are movable pulleys and this is a fixed pulley. Remember, this is important. This remember. If this goes by x, this goes by 2x. If this goes by v, this is 2v. If this is a, this is 2a. Right? So I strike at two places. One is tension relations, the other is acceleration relationships. I can start from here, T. Obviously, if tension in this string is T, over here T by 2 and over here T by 4. I don't do it. I go the other way. I say T, 2T, T, 2T, 2T, this also 2T, and in this it will be 4T. What difference does it make? It makes a good much of difference. As far as, let's say, where you can commit mistakes. Avoid friction in your entrance examination. Otherwise, mathematically, concept-wise, it's absolutely fine. You take this as T, T by 2, T by 4. But dealing with T by 4, there are chances that you make a mistake. So take it as T, 2T, 4T. Then going to the acceleration relationships. This is A. From here to here there is a single string. So this also goes with A. There is a single string only. If this goes by A, now I can see this structure over here. If I pull it by A, this end is fixed. So anything whatsoever is straight over here, it has to move it to A. So what is straight over here? The pulley is straight over here. So the pulley moves it to A. Now I concentrate purely on this. If this moves by 2A, this is fixed. So once again, it is a repetition of this only. So if this goes by 2A, so this has to move by 4A. Now its job is simple. For this, 4T is here, 100 Newton is here. So equation for this. Now Newton second law, which says, you know, that is, don't say F is equal to mv. It is F is equal to dp by dt. Net force is rate of change of linear momentum. It's only when the masses are same, constant. Then you know momentum is, when you say F is equal to dp by dt, then P is mv. So Fr is equal to d by dt of mv. Now if m is constant, then only it can come out. So Fr is equal to m dv by dt is equal to mv. Hardened cases like where you are dealing with the rocket propulsion also, conveyor belt, where you are putting some sand regularly continuously, or you are moving some of the things, then the mass is changing. Then you cannot take this mass out. So F is equal to mv. So now let's apply F is equal to mv. For this, 100 Newton is here, 40 is here. So net force is 100 minus 40, net force. Which way? Because it is accelerated downward, so net force 100 minus 40. Net force is equal to mass. Mass is 10. Acceleration is 8. Now going to this block. Make a equation of blocks. Now do not try to make a equation of the pulleys. They are massless. You won't get anything. So this is P is equal. Motion is purely horizontal. So see all the forces along the x-axis only. Do not bother about the y-axis motion. There is no y-axis motion, so all the forces along y-axis they are balanced. Net force is equal to 0. So do not clutter the diagram with mg is equal to normal direction. That is not required. So over here this is T is equal to mass. Mass is 5. Acceleration is how much? 4a. You can, within just 2 lines you can solve the answer. So I think it makes the things now much simpler. Let me now play with this further and see see what are the other things, simple things we can do with this. Now let me take a case where I have a block over here, string goes over here, this is tight, and over here I have 10-gauge block over here, and let's say 5-gauge block over here. This wall is not required, frictional surfaces. This slide over here. So now someone says, give me the action of 5 kg or 10 kg of the tensions. One and same thing, multimeters. As far as understanding the concept is concerned. So do I see over here fixed pulley and movable pulley? Yes, I do see. This is fixed pulley, this is movable pulley. So if movable pulley is there and that too, one of the ends is tight, it's fixed. So my mind automatically conditioned goes at this. If this goes by x, this goes by 2x. But over here in questions like this, you know that we are bothered not about the x or velocity relationships, we are bothered about the acceleration relationships. So you directly say this goes by a, this goes by 2a. Now the nuances of this, it also means if I pull this instead of, if I pull this by a, this will go by 2a. Now, but if I pull this by 2a over here, so this pulley will go by a. Or if this goes by a, if I divide both the things, so this has to be a. That's simple geometry, mathematical geometry, nothing difficult. So if I pull this by a, this will go by a by 2. This okay? So now let us understand how to do this. One is I strike at the tension relationships. Tension, I call this over here in T. In this string connected from the center, I know it is 2T, so over here tension is 2T. Now comes acceleration relationships. Not the challenging part. Don't think acceleration relationship is difficult. As soon as you make up your mind that it is difficult, you set up the blocks. See, it may be difficult, but you will understand. Have that confidence. The things are much easier. Don't worry. So I suppose I say A. Now if this goes by A, this will go by what? If this setup, I move it like this. If this goes by A, this goes by A by 2. If I from horizontal, I make it vertical. So when I make it vertical, it is exactly same. So if this goes by A, this end is going to go down by A by 2. If this goes by A by 2, from here to here, this goes by A by 2 only. Point clear? So then you can say that if you intend to take, you wish to avoid fractions, you can say this is A and this is 2A. That also you can do it. Right? But let me say, now stick to this only. Initial phases of understanding. So this is A, this goes down with A by 2 and this goes this way by A by 2. The rest is simple, you know. T is here. What is the force? Acting this way, 100 Newton, mg, 10 into g, 100 Newton. Over here, this is 2T. Equation for this. 100 minus T is equal to mass. Mass is 10 into A. That is equation number 1. For this one, pure horizontal motion. So see the forces which are purely along the axis only. So this way, it is 2T. Net force, mass. Mass is what? 5 into acceleration, A by 2. Second equation, you can solve the two equations to get the answers. Tension and acceleration relationship. In this question, now we have all the frictionless surfaces. This is a fixed pulley, this is a movable pulley, right? Now let's say the first confusion is which way the system will move. Which block will go down, this one or this one. So if I see over here, this is mg, 100 Newton, and you know when it is on the inclined plane, mg is here, mg cos theta, that is normal reaction equal to mg cos theta, and this way it is mg sin theta. So mg sin theta, let's find the value, mg sin theta, ms m into g 10 sin theta, that is half. So this is 75 Newton. Over here that goes out to be 100 Newton. So which way the system will move? So we'll say that this way. Or many times that is students they go for, they assume any direction. Let's say it goes this way, acceleration A. They make some equations, and then they say suppose A comes out to be positive, it means the assumed direction is okay. And if it comes out to be negative, it means the system will actually move in the other direction. That is fine. But many times this logic will not work. There have been cases you can create equations where I make this as theta 1, I make this as theta 2. I talk about the friction also, mu s1, mu static 2, and the whole system will be stationary. Whereas if you make that relationships, you may get some acceleration which may not actually come out to be right, correct? So now, without depending too much on mathematics, how we can just see and simplify the things and see which way the system will move. Do not directly compare 100 Newton, 75 Newton, so the system is going to move this way. No way. How to see it now? See, there is a movable pulley. You fix it. You jam this pulley so that this is not rotating now. You have fixed it. If you have fixed it, so it means that is tension in this string is, because now this is not moving. Why? Because you fixed it. So tension this is 100 Newton. So from this side if you see, that is, so over here I see a force of 100 Newton. This way is 75 Newton. I fix it, I jam it, I don't let it rotate, and then this and this they work as two strings. Now I see what is the force which goes through this in this string, this side, and once I approach from this side. This is stationary, acceleration 0, rather acceleration 0. It remains stationary, that's why acceleration equal to 0, 75 Newton this way. So tension has to be 75 Newton. 75, 75, 150 Newton. So this side is trying to rotate this with the force of 150 Newton, whereas this side is trying to rotate with the force of 100 Newton. System will move this way. This pulley will rotate this way, as a result, this will go down. So this block will go down, this block will move up. Now do not say tension this thing is 100 Newton, tension this is 150. Please do not say that. We have used this only to find out that is which way the system is going to move. Once that is done, that's all. It has only this much job only. So now I go back to the previous thing, that is how we do it. Do not say now tension is 100 or 150 Newton. No, it is not that. We have to find out. I see that is this will go down, that's all. So if this tension is T in this string, so in this or in this it is 2T. I draw a circle onto this for the free body diagram, or before that let me go for the acceleration relationships. So if this goes by A, if this goes by A, this will go by A by 2. If this goes by A by 2, this goes out by A by 2. For this equation, for this 2T minus 100 is equal to 10 into A by 2. And for this 75 Newton this way, A is this way. 75 minus T is equal to mass is 15 into acceleration is A. You can solve the two equations and you can get the answer. It's a simple job. So you see that the questions involving movable pulleys, they are simple. You have to just strike at two places. One is acceleration relationships, the other is tension relationships. Right? Sufficient for the day. Thank you very much.